Hi, everybody. This is problem 18.3 of Electrical Engineering 235. Uh, this problem appeared on one of our daily tests today. You can see the date here is uh, Wednesday, October 5th, 2016. But the reason that I wanted to discuss this problem with you in particular is that the choices for your answers, one of the choices is incorrect. Well, actually, I guess I should say all of the choices are incorrect. The one that was intended to be correct, which was choice B, is actually incorrect as well. And so I want to make sure that you understand why. So once again, today in class, it was indicated that this choice B was the correct answer. So I'll say indicated as the correct answer in class. You might recall that I made the key available to everybody today for this problem and also for problem 18.4. And on that key, I indicated that answer B was the correct answer for problem 18.3, but actually it has an error, and I want to make sure you understand the error. Briefly, I'll go ahead and just tell you right now the error is that the first two minimal sums here given in answer B are correct. This first one here is correct, and the second one is also correct, but the third one is incorrect. And we'll see why this third one is incorrect right now. And we'll also see why the error was made. So let's go ahead and solve this problem together now. We have f of w, x, y, and z is equal to the sum of the minterms 6, 7, 9, 10, 13, plus don't care conditions in cells 1, 4, 5, 11, and 15. So let's go ahead and draw the Carnot map for this problem. We have solid ones in cells in cells 6, 7, 9, 10, and 13, and then we'll have squiggly ones in cells 1, 4, 5, 11, and 15. So cell 6, if we start counting, this is cell 6, and here is 7, here is 9, here is 10, and here is 13. Those are the solid ones. And then the squiggly cells in cell 1 and 4 and 5 and 11 and 15. So now, as usual, the next step will be to find the prime implicants. Clearly, there are no groupings of 16 one cells. So then we go to 8, and although we do have more than 8 one cells here, we don't have any rectangular grouping of 8 one cells, so that's not a possibility either. So then we go down to 4, and we have several groupings of 4 one cells. So let's look at those. One of the first that pops out is this grouping right here. and so we'll briefly sketch it, and we can see that since W is frozen and equal to 0 and X is frozen and equal to 1, then that's the name of that prime implicant is W prime X. Another grouping of 4 that pops out at us is this one, for which Y is frozen or constant and equal to 0, Z is constant equal to 1, so that is Y prime Z. And then another grouping of 4 that pops out at us is this one here in the middle. And for those 4 cells, X is constant equal to 1 and Z is constant equal to 1, so that is XZ. And then still another grouping of 4 is this one right here. And notice that W is constant equal to 1, Z is constant equal to 1, so that's WZ. And that is the end of the groupings of 4 1 cells. So now we go down to groupings of 2, and all the groupings of 2 are already contained within groupings of 4 except for 1, and that is this one down here. And so we have that. And notice that W is constant equal to 1, X is constant equal to 0, and Y is constant equal to 1, so that is W X prime Y. So that is all the prime implicants for this function. And now we want to look for essential prime implicants. And we began that process by looking at essential 1 cells, and the only essential 1 cells here are this one and this one, and the first one up here is in W prime X, and the second essential 1 cell down here in the corner is in WX prime Y. So those are the only 2 essential prime implicants, and remember that those will be in every minimal sum. So now we finish up the problem. We list our minimal sums. And again, in every minimal sum that we have, we must have those essential prime implicants. So let's go ahead and start with that. W prime X or WX prime Y. Now, by including those 2, we have taken care of everything here. So I'll scratch through this. And by that is W prime X, and then by including WX prime Y, we have taken care of this. And so now we ask ourselves, what remains to be done? And the only 2 remaining 1 cells that must be accounted for are these 2 right here. In other words, cell 9 and cell 13. Those 2 are not yet accounted for in these 2 terms, and so we have to find the most efficient ways of accounting for those 2 terms. And one way we could account for those 2 terms would be, as you can see, through the addition of Y prime Z, because as we see right here from our little sketch of Y prime Z, that is all of the cells right here along the second column of the kernel map. And if we included that, that would include both of these 1 cells. So we say or Y prime Z, and that would finish it right there, because if we included that, that would include both of the remaining 1 cells that have to be accounted for. So that would be one minimal sum, or another. And remember, again, we always start with what's essential. So we have W prime X or wx prime y. And now another way that we could capture these two one cells would be through the inclusion of this grouping of 4 down here at the bottom, which is, as we can see from our sketches, that is WZ. And notice that both of these sums have the same number of literals, so both of them are minimal. Neither one is preferable to the other because they both have the same number of literals. But that's it. Now, in the problem choice B up above, you can see, you can see that the two checked answers here are the two that we've just found, but then there was one more, w prime x or wx prime y or xz. And why is that not correct? Well, xz, as you can see from our sketches here, is the 4 terms in the middle, and if we added those 4 terms to our 2 essential prime implicants, which are indicated here, then we would miss this one right here in cell 9. So that would not, it would still not account for all of the solid ones, and therefore it would not be a correct answer. Now, you might wonder, well, how was this mistake made? When I looked back at my work, I think what happened was that when I solved this problem with my poor handwriting, I think I mistook the mark in cell 9 for a squiggly one rather than a solid one. And please do verify for yourselves that if that were a squiggly one in cell 9, in other words, if 9 were not over here listed among the mandatory minterms in this function, if it was listed as a don't care condition, then choice B would, as it was originally given, would indeed be correct. And you should verify that for yourselves, that if 9 instead of being listed over here in the mandatory one cells for this function, is if it was listed as a don't care condition, then the originally listed answer B would be correct. But it is not a don't care condition. It is one of the mandatory terms, and therefore answer B should be changed. You should not have this last part here to answer B. You shouldn't have that last minimal sum, only the first 2 minimal sums. So be careful about that, and in fact I think that this is maybe a good mistake to make, because I think what it really indicates, I mean, after all, in haste, it's very easy to write down a 1 in such a way that it might look like a squiggly one, or vice versa. So what I would recommend that you do is, when you do these problems, either for the daily test or more importantly for the midterm test or the final exam, that you bring along 2 different colored pens with you. And if you'll write down the don't care conditions in one color and the mandatory conditions in another color, then it will be much less likely to make a mistake like this. But anyway, that concludes the discussion of this problem. Answer B was indicated as the correct answer on the key that was provided in the classroom, and so anybody who marked answer B will receive full credit for it, so don't worry about that. And so that concludes this little note, and good luck for you in your preparation for the midterm exam.